Everyone. I want to just show you a few things that might be helpful in your work with Raspberry Pi, wiring up the breadboard, filling in your to-dos in the code, that sort of thing. So this code that we have, let's start with the code. For Module 5, your Morse code simulator, this code is it has all the fundamental stuff already there, GPIO libraries, state machine libraries, threading and time, and main classes and methods. And your CW machine class is the sort of the core of the program. Implements the state machine and sends the Morse code. So let's take a look at that. Here's your managed display class that controls the LCD screen. CW machine is our state machine implementation class. The purpose is to send a message in Morse code, blinking the red light for a dot and the blue light for a dash. And of course the time, the pulse width modulation time is going to be different for the dot and the dash. And so we have two LEDs, 18 and 23. Now remember, we had it wired up, the red LED wired up to GPIO 18 in module 1 and 2, and we tested that, and then we moved it for this assignment down toward the bottom of the breadboard and put a blue LED next to it, but it's still wired up to GPIO 18 because of the jumper configuration. So just because the LED itself is moved, the jumper keeps it wired up to the same GPIO pin. And then our messages are to SOS or OK. And our Morse dictionary, our do dot and do dash, off, TO dash, dash TO, off. Do letter pause, do word pause. So all of this is already implemented for you. And then you have some to-dos. So go through those carefully. And here I have some of them filled in just to show you. It says to add a single line of code necessary to blink the red light for 500 milliseconds one time. So we have 0.5 for 500 milliseconds. And then it says to do. I put this one up above the to do, but this goes with this. And so red light forced off, self red light off. Blink the blue light, 1500 milliseconds, 1.5, blue light off. So you get the idea. There's just a few of these to-dos, but go through those carefully. And you sleep, pause for 250 milliseconds, 750 milliseconds. And these are all to-dos. Sleep 3,000 milliseconds or 3 seconds. Now, once you get down here, you do have, in toggle message, you do have a bit of logic to write, but it's It's pretty obvious. It's a toggle message. So whatever your active message is, you want to set it to the other message. You've got two messages. So for each X in Morse, if we're supposed to send a dot, we send a dot. And notice, I don't know if you noticed when we were up looking at the do dot and do dash, but it's a toggle. It's going to set it to its, it's the two states are on and off, so it's going to set it to the opposite state from what it currently is, and that's why you want to send this twice. So it'll turn it on and then turn it back off. Same here. And same here. And finally, I believe this is your last to-do, handle the button press. Now they tricked me when there were two photos of the button, the color of the button cap in the instructions. The first picture showed a red cap, I believe. So I grabbed the red cap and put it on. It said you could pick any color you want. So, but I picked the one that they had in the picture. Well, then the next picture that showed the button in place and everything configured, it was a different color. I think it was green. Obviously, that doesn't matter, but I would have preferred to be in sync with this green button object here. But once I had it on there, I was afraid to disturb the button because it was a bit of a chore to get it seated just right. In fact, the first time I attempted to use the button, I got no response, and so I shut down the Raspberry Pi and I pressed it in a little more firmly, and there was some give there, so it needed to be seated better in the breadboard, and so after I did that, I turned it back on, and the button worked. So if you're having that issue, that could be the problem. Now, one other thing, there's a resistor that brings over some power from the 3.3 volt power rail. Now, if your breakout board, your breakout board has some pins coming out of it, a plus and minus pin for so a power and ground pin for the 5 volt and the 3.3 volt. Now, depending on which end of the breadboard you put your breakout board on, you could end up with the plus pin going into the blue column on your power rail on one side or the other. Probably it's going to be correct on both sides or not. So if you have your resistor in the red power column in the power rail, 3.3 volt power rail, and it's not working, then I recommend checking to see, and this is very fragile. I hate to pull the thing over here, but I would recommend checking to see that your 3v3 plus pin is actually plugged into the red column. And if it's not, and everything else is working, you probably don't want to take the time to switch ends right now. And I would just simply use the blue rail at that point as if it were red, because that's where the power is going to be. If your breakout board has the plus pin going into the blue rail, then that's in fact the red rail. So just something to be aware of. So anyway, that's all of your to-dos for that one. So let's just take a quick look, and let me open up a terminal. Here it is. So I'm going to SSH into my Raspberry Pi. Present working directory, PWD, that just tells me where I am. So I'm in my home folder. So let's see, what do we have? LS. Of course, if you're familiar with these Linux commands, that's fine. But I've been hearing from people that not everyone is familiar with these. So I just want to take the opportunity to go over these. So LS tells us what we have inside that folder. So we have a file, code zip, and then some other folders. So I'm going to go to my desktop, and you may not have a desktop. If you recall my early announcement about I installed a GUI desktop on my Linux server because it didn't have one. You didn't have to do that. It wasn't a requirement. So if you don't have a GUI desktop and you're comfortable with that, that's fine. But since I do, that's where I have to go, because that's where I've been putting everything. So CD, change directory, just like in Windows. Now let's see what I got in my desktop. Okay, I've got the CS350. Code. CS350. Okay, so now I'm going to go to Module 5. And I've made myself a playground folder, because I don't like to modify the only existing copy of a source, an original provided starter code. So I copy it to a playground folder and modify that one. That way, if I totally mess it up, I've got a way back. So, just run that one. This is milestone 3. I just misnamed it. So this will be the same code we were looking at over here. Okay, so it is running now. I guess you can see the blue light and the red light. By the way, when you're working with these breadboards, I recommend getting one of these, especially if you're an old guy like me. So anyway, that's working, and you can't see the LCD, but it is working. Now I'm going to put some stuff in the announcement that'll accompany this video about some common mistakes that I found myself making, and I may have mentioned this earlier in this video, but I realized when the LCD wasn't working that I had failed to put one of the jumpers on. It was the one to GPIO 17. So when it wasn't working, and I went into the code, the display test code, and I started looking at it. Okay, these are the GPIO pins it's addressing, and then I would go to the board and verify that it was jumpered, and sure enough, one of them was not. And so then I went back to the instructions, and the instruction was clearly there to put a jumper on that adjacent to that pin, but I had not done it. So I fixed that, and then the LCD was working great. So it is easy to miss something in these instructions. And another common mistake I found myself, I assume this is a common mistake, it seems to be for me. At one point we were instructed to put a jumper into row 54, and so I zeroed in on the 55, and then I put the jumper on the wrong side of the 55, so it was actually in 56. So just those are the types of things to be wary of, and probably some of the first things you need to check if you find yourself having to go back over and double and triple check your wiring because something isn't working. Those would just some of those common mistakes probably going to get you. Well, that's and I'm going to send an accompanying little video I made on my phone that has some close-up looks at the wiring and shows you the LCD and everything. But it's difficult to give you close-up views of the board in a video like this, because after all this work, I'm hesitant to pick it up and move it around too much. But I did get myself a spare board and breakout board and breadboard, and what I should do is maybe before the next video I'll wire this one up exactly like the one that's actually plugged in and working, and that way I could actually show you some close-ups. So we have that to look forward to. Anyway, that's all I can show you here. Um, Good luck with this assignment, and as I said, I'll send some close-up, a video with some close-up shots of the wiring of the breadboard and the button and all of that. I'll see you next week.